Okay, so the next thing we'd like to talk about is the sources of errors in sample survey. When we are trying to deal with or choosing different sampling scheme in sample survey, we need to consider the cost. We need to consider how convenient, how easy to conduct the sample survey. So one other thing is we need to reduce the errors. What are the errors? Usually we talk about the errors is like the sample estimate we obtain from the sample would be closest to the true population value. In other words, the difference between the sample estimate to the population true value is minimized, then we tend to choose that sampling scheme. Then statistically, we talk about sampling error. Okay, so the sampling error is classified as the difference between the estimate based on the sample and the true value based on the population. So we want to reduce that sampling error so that we have closer of the estimate true to compare to the true value of the population. The second area we talk about is non-sampling error. Non-sampling error is not anything that depends on the sampling scheme. It's really some technical or human errors which this can be reduced if we can design the sample survey method better. So in other words, non-sampling error would be, for example, would be coverage error, non-response error, measurement error, interviewer errors, respondent errors, etc. So I believe Professor Ho has already talked about what this non-sampling errors would be. For example, the coverage error that if you conduct a sample survey, coverage error would occur if we do not have a full sampling frame that is reflecting the population. Let's say the frame we obtained and if we choose to sample from that frame, which is not a full picture of the population, then we did not really cover the full population. So that's the coverage error. For example, one very classical example would be if we want to estimate the average hours of study for university student, for example. Then the population would be all university students at Hong Kong U, for example. But if you just design your sample or design your survey based on the frame or the students who go to the library to study, then you have a list of students going to the library, but apparently those students does not really cover the whole entire population or all of the university students. Then if you choose a sample from your frame, it does not cover all of the population of the university student. So apparently we will end up having a higher coverage error. And at the end of the day, the number of hours or average hours of study will be higher than the true value, because those going to the library likely to have higher average hours of study, right? So that would be the coverage error, but we can minimize it if we obtain a better frame, right? Non-response error, that means the interviewer does not respond. So again, we can avoid that. Like if you decide to conduct a telephone interview, then if you decide to call during the daytime in the weekdays, then as a result, likely the response rate will be very low, because most of the people or most of the residents, they went out to work and they did not respond. So as a result, we have very low response rate. Again, we can avoid a better design of the survey. Measurement error, interviewer errors, those are the human errors. Measurement error would be like with the calculation of the measure or the change of the decimal places or the calculations, etc. Again, we can reduce it. Interviewer respondent error, very much related to how we train the interviewer. If we are well trained, given good training for the interviewer, then they they could ask better question or describe it more truthfully, right? So to reduce the interviewer errors, respondent error on the other side, if the interviewee did not answer the questions or the questionnaire to the true value, then likely that would be a very high respondent error. There will be one example on the tutorial class that we talk about the how we deal with some of the sensitive questions for the respondents. Okay, instrument error and mode error is more about how we use the telephone or the face-to-face or the different kinds of the survey that we choose to use. So after all, the non-sampling error, we can try to reduce them. However, for the sampling error, we can't easily reduce them. It's really very much depend on the sampling scheme that we choose. For the calculation, random error variance would be referring to the sampling error. Systematic error would be the bias. Usually that would be the as referred to the non-sampling error. Okay. Mean square error, this is the total of both of the errors. Most of the time we want to reduce the mean square error so as to determine which sampling scheme would give us the best or the desired precisions at minimum cost. So in this course, at the end, we will talk about different sampling scheme, and then we will compare. Under a certain situation, we compare different sampling scheme and to come up with the best solution or the best choice with the minimized variance. So how do we look for the minimum variance or the unbiased estimate when we try to determine the different sampling scheme? Usually we would specify a bound of error, B, that is the tolerant level of we can tolerate with that error. The error in an absolute terms would refer to the true value minus the estimated value. So with a hat, that would be referring to the estimated data we obtained from the survey. Theta would be the true value. So in absolute terms, if the difference is less than our tolerated bound of errors, then if that's achieved at a certain probability of times, then we think this is acceptable. And assuming that our sample would exhibit a normal distribution for the large sample sizes, we usually assume they are normally distributed like a bell shape. So we would say that we prefer to have that error of estimate less than our bound of error at 95% of the time. Then in this case, if this is a normal distribution, the bound of error B would equals to the critical value of Z multiplied to the standard error of our estimate. And if that's a normal, the critical value would be 1.96 times the standard error of our estimate.